S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
If we want to understand how the light travels in space, how the light is formed by the different wavefronts, so that principle is given by the Huygens. Now we will understand in the Huygens principle. So myself Narendra Kaur, let us begin this topic. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. So according to Huygens principle, it is used basically in order to understand how the light travels. Firstly, we know that the light that is made up by the wavefronts. What is a wavefront? That is a part of the light by which it can be represented. We know that if this is a source of light, if this is a point source, we know that it will spread the light over here in a spherical wavefront. So the wavefront, that is a spreading of light, how it eliminates the light in space, that is known as a wavefront. That means spherically, so the light will travel in the space. So this is called the wavefront of the light. So according to Huygens principle, each point at the wavefront, so there is again a point in the wavefront that will again spread the light. So this will again spread light in the space. Again each wavefront or each point on the wavefront, so that will act as a source of the secondary wavelength, or these wavelengths are the basically vibrations, or you can clearly see that how the light travels in space. We know that for the spherical wavefront, the light will travel like a sphere. Now if you take the source of the light that is in the cylindrical tube, then how the light will travel? So the light will travel in the form of tubes over here. So that will be travel in the form of tube. So this is the cylindrical wavefront for the light. So depending upon the source or the shape of the source which is present over there, the wavefronts or the wavelets that will propagate in the space. So according to Huygens principle, the each point on the wavefront that will be act as a new source of the wavelet, and that wavelets will propagate in the space and which represent the propagation of light in space. So these wavelets will represent the how the light will travel in the space. So each source, each point, so now this is a combination of multiple points will be there. So each point will act as the source of wavelet over here. So these wavelets now will superimpose on each other to give us the complete wavefront or the complete light. That means how the spreading of light is done over here, that is given by the Huygens principle. So this principle is basically used to give the how the light will travel in the space. Now again there are the multiple of points, or you can see that there are the infinite number of points which are present on the first wavefront. Then again each wavefront that will act as a source of secondary wavelength. So these wavelengths will also travel in the space. Again it will act as a source of secondary wavelength. Now all these wavelets, they will superimpose on each other. So how they will superimpose on each other, for this that will be explained by using the superposition principle. So Huygens principle, this source will spread the light in the form of sphere. How that light comes in the form of sphere, and how these wavelets, each point on the wavefront, now this is called wavefront. Wavefront is what? How the light is given by the source, that will act as a source of new wavelengths, and these wavelets will superimpose on each other, and which is responsible for the propagation of these wavelets in space. Now next is the superposition of waves. Now we know that here the each source that will act as a source of the secondary wavelets. So these wavelets now travel in the space. Again we know that the wavefront that is in the form of waves, or you can say that the light that is travel in the form of waves always. Now if the light is travel in the form of waves, then there comes a principle of superposition. How these wavelets superimpose on each other. How these wavelets superimpose on each other. Now if there are the number of waves, that means the secondary wavelength or the wave front from the light source. Here the wave front which is coming from the light source, that is represented in the form of wave. That means wavefront is represented in the form of wave. Now these waves, we know that the wave that can be represented as a sinusoidal component, and which gives us its phase and amplitude both. Means there the phase is presented and the amplitude both are presented. So the wavefront that is represented like this. Now these two waves or the more than two waves, they will superimpose on each other to give us the resultant wavelength. Because if there is a source, if this is a source S and it gives us, these are the secondary wavelets which are produced from it. Now these secondary wavelets, they will superimpose on each other. Now here they will superimpose on each other to give the resultant over the resultant on this screen over here. So these will superimpose in each other. How they superimpose? So this is given by the principle of superposition. So according to this principle of superposition, the resultant displacement of the several waves, because there are the large number of waves which are travel in the space, that is equals to, their resultant is equals to vector sum of the individual displacement which is produced by each waves. Means we know that the wave is traveling in the space, that is taken in the form of vectors. So that's why their resultant, now it's a resultant, the resultant is given by vector sum of these two. Now this is in the positive direction, again this is in the positive direction, and this is also in the positive direction. Now the resultant of these three wavelet y, that is given as y1 plus y2 plus y3, because they all are in the one direction. So that is given by superposition or vector sum of these three displacement. Now the principle of superposition, that is considered like this. Now if we are considering the waves which are traveling simultaneously in the space, so in this case it is observed that the net displacement of the element at any point, that is equals to algebraic sum of the displacement due to each wave. Now that is algebraic sum means as the numbers are added, so in the similar way the displacement of the waves that can be also added. So this is added just like of number. So that's why this is the algebraic sum of the displacement given by the each wavelength. Second, now we have been consider the two waves. Consider the two waves which are traveling in the space with the displacement y1 and y2. What is y1? We know that the displacement, here the waves are continuously travel in the space, so their displacement is varying. Now y1, that is their wave which is combination of or which depends upon displacement as well as time. Again y2, it depends upon displacement as well as time. So we consider here the two waves. So here we are considering the two waves which are travel in the space and their distance is continuously changing with the time because they travel in the space. Now when these two waves overlap with each other, their resultant is given by y. What is y over here? Now their resultant. If they are in the same direction, their displacement will be added up. Now when they are in the opposite direction, their resultant will be subtracted to each other. So the resultant that can be represented like this. Now mathematically we can show over there. So the resultant of these two that can be represented by combining these two because they are traveling in the same direction. So this is the principle of superposition. So as per the principle of superposition, we can add up these two waves in order to get the resultant wave. Now we know that for the moving wave, the function y1 that can be represented by function, now this y1 that is a displacement, they are continuously in the moving direction. So that can be represented as function of x minus vt. So this is a first wave, second and so on. Means when there are the large number of waves are present instead of 2 waves. So the resultant wave, that will be equals to sum of these 2 waves, all these waves. So if there are the n number of waves, so that can be represented as summation of I varying from 1 to n f of I x minus Vt. So that can be represented like this. So this is a combination of these 3 waves. Now this is the how you can mathematically represent the wavefront. We know that the light travel in the space, and when the travel in the space, at each point, if this is a source, then each point of this, that will act as a source of secondary wavelength. We know that when we on the, for example, let us consider we on the bulb over here, so that it will give the light over the in the form of sphere around this point. So that means this is in the spherical form. That means each point, so there are infinite point over this space. So each point that will act as a source of secondary wavelength. That means from this we will get again the waves. From this point we will get the waves. So all these, there are the n number of points. So all the waves, they will get superimposed on each other. Now if the one screen is present over here, so at some particular points we will get the light due to constructive interference or due to interference of all these or the combination of all these wavelengths at each and every point. So we will get the resultant displacement. The resultant displacement that can be done. We know that with the time, as the time and distance goes on increasing, the light intensity of this source, this to this point, that will be goes on decreasing. So with the time, as the distance goes on increasing, and with the time also its intensity goes on decreasing. So on moving the screen from this to this point, the resultant of these wavelets which we are getting, so here this and this point, the resultant that will be altered over here. So that's why the displacement is taken as function of x minus Vt. Now we know that displacement has both magnitude and direction. So that's why the resultant is taken as combination of magnitude as well as time over here. So this is a principle of superposition by which we can calculate displacement of the resultant displacement of the point source or any source shape of the source, that can be any over here. So by combining these two, we will get how on moving from one point to another point, the wavelets will superimpose on each other. So now let us take a short break. Now till now we have understood what is the Huygens principle, how the secondary wavelets travel with the light, and how on traveling the principle of superposition is applied in order to calculate the displacement. When we come back, we will understand when the waves is represented in the form of phasor diagram, means there is a presence of amplitude as well as phase, how the combining or the superposition principle is applied in order to calculate the resultant wave for the source.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now before break, we have understand what is the Huygens principle and how the superposition of wave is applicable to it. Next we will understand कि after the application of superposition principle to the waves, how the resultant amplitude that will be calculated. Now in order to understand over here, let us consider the wave that is traveling in the space. Now we know that the wave that can be represented by combination of these two. Here A represented the amplitude of the wave and this represented the phasor diagram that will represent the phase over here. Now let us consider there are the two waves which are traveling over here by the phase difference of phi. Now if this is the resultant, or you can say that the representation of the wave with amplitude and the phasor diagram, or with the phase where kx minus omega t represent the phase of the wave. Then again the second wave that will be given by y2, which is equals to sine kx minus omega t plus phi. Let us consider phi, that is a phase difference between these two. Now we know that these waves here, omega t represent the angular frequency for them and k represent the wave number. Now for both the waves, amplitude is same because they are we are considering over here the waves which are traveling with the same amplitude and the same angular frequency. So both these waves, they have the same angular frequency. Here omega is same for both, wave number is same and the amplitude is same. So they have the same wavelength and the same amplitude. We know that omega, that is equals to 2 pi nu. What is nu here? Nu is the frequency, or you can say that it is written as 2 pi c by lambda. So that means if the omega is same for both, that means now 2 pi and c, they are constant. Then lambda, that will be same for both. So that means they are traveling with the same amplitude and same wavelength. Now the resultant, that will be given like this. Now when these two waves, they superimpose on each other. So due to superposition principle of these two waves, when now they are superimposed on each other. So the resultant, that can be given like this. We know that the resultant of these two waves, that can be written as, now the two waves superimpose on each other. So the resultant will be equals to sum of these two. So now in order to calculate the resultant, now we know that A, that will come out. So here comes sine now this will become sine C plus sine D. Now applying the formula over here, the sine C plus sine D, we will get that is equals to 2 sine C plus D by 2 into cos C minus D by 2. So apply this formula over here. We know that we are getting here sine so that is equals to 2 sine. On adding these two, we will get over here so that means we will get so the resultant of these two waves, the yxt, that can be written as 2a now what does it mean? That means when the two waves superimpose on each other, so their angle and amplitude both are goes on changing. What is phi over here? Phi is constant. Phi, that is a phase difference phi is a phase difference between two waves, means the y1 plus y2 xt, they are traveling over here. Now if this is the phi 1 and this is the y1 over here and that is a y2. Now if phi is a phase difference between these two, so this is the phase difference. Now we know that here phi is taken constant over here. Then the wavelets, this is a source over here, the wavelets are produced from this source. So now each point that will act as a source of secondary wavelength. Now these wavelets, they will superimpose on each other at each and every point to give the resultant wave. So the resultant wave, that can be obtained by combining these two. So these two waves, these two wavelets, you can clearly see that Now if this is a source S, so that means, so if this is a S1 point and that is a S2 over here, so in the short form that can be represented like this. So there comes a phi difference, the phase angle difference between these two. So now these two will superimpose on each other to give the resultant over here. Now their resultant is represented like this. So you can clearly see that now phi is constant between them. So 2a cos phi by 2, that will represented another amplitude over here, and this will represented another phase difference over here. So on the screen when we get the resultant, so the resultant wave that is equals to 2a now when you calculate the difference over here, so this is the amplitude. Now write this as a dash, and now the phase for the resultant wave that is equals to kx minus omega t plus phi by 2. Now the phase of the resultant wave is also half of the phase between the two waves, because for the two waves the phase is phi in this case, but the resultant wave the phase is phi by 2 over here. So that means the resultant amplitude that is equals to a dash now where a dash equals to 2a cos phi by 2. So this will give us the amplitude of the resultant wave. So this is the amplitude of the wave that is constant over here. So that means we are getting something is in the initially the amplitude is a. That means in the resultant we are getting a wave with the more amplitude. So amplitude of the resultant wave that will be enhanced because of phi and a. These factors will enhance the a. So that will be more than a in this case. So this is enhanced. So that means the resultant wave, or when we superimpose the two waves, the resultant wave that will be enhanced. And in the second thing, what is the phase over here? Here the phase is kx minus omega t plus phi by 2. Means when for the resultant wave, the phase difference is half of the phase difference between two waves. Means the phase difference between two waves is phi, while the resultant is at the phase of phi by 2. That means if we represent it like this, if this is the initial one wave and that is the second wave, here the angle between them is phi over here, then the resultant wave is also like this with a higher amplitude. The phase difference between, if this is the two wave, here S is the S1 and S2 and there is the source. Now for the resultant wave, if this is the resultant wave, so for the resultant wave the phase will be phi by 2. So the resultant wave that can be calculated over here. Now this will represent how the superposition principle in the form of waves is applied, and phase that is get modified and the amplitude is get modified. So all these things are described by using the superposition principle. So according to superposition principle, the resultant wave that is a sinusoidal wave, because as the initial waves they are sinusoidal wave, so automatically the resultant wave is also sinusoidal wave, and also it is traveling in the positive direction because here the amplitude is positive, because now they are traveling in the positive direction. So that's why, and also the phase angle that is a half of the phase difference of individual wave. So the phase difference that is half of the individual wave, because in the two waves the phase difference is phi, but here we are getting the phi by 2, and also the amplitude is get enhanced, which is 2 cos phi by 2 times the amplitude of original wave. So this is about the superposition of principle. After the break we understood when the superposition of the two waves is done, how their amplitude and their phase that is get modified. That means the resultant wave have more amplitude or higher amplitude, and the phase difference is getting half to the phase difference between the two taken the original waves. Thank you. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe the this video, and also you can press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.